In this problem, what we're going to be doing is you're going to be given a point on the terminal side of an angle, and you have to find all 6 trig functions. So if you would, pause the video and see if you can try to do this one on your own. Alright, what I did first was I simply drew out the angle. The angle starts at 0, it goes counterclockwise, and it stops here. The terminal side is, formed by the origin attached to that point. So what you want to do now is figure out, okay, what's my reference angle, and how can I set up the triangle? Because once you set up the triangle, you can then find this, right, using Pythagorean theorem. So the reference angle is actually going to be between here and here. Now, how do I know that? In quadrant 1, your reference angle is just the angle. Once you get to quadrant 2, it's 180 minus the angle. If it's in quadrant 3, it's the angle minus 180. In here, it is 360 degrees. Let me put degrees. 360 degrees minus theta. So it's going to be the leftover, right? This small little portion right here. So let me draw this out. I'm in quadrant 4. Now my x is from here to here. That's going to be 4 units. Now that goes down, parallels the y-axis. So from here to here, it's -4. To find this length, you set up the Pythagoras Theorem. This is your right angle. It's your angle right there. So let's label this x, because you just love using x's. So this is the legs. The sum of the squares of each leg equals the hypotenuse squared. So that's going to be x squared equals 16 plus 16, 4 squared and -4 squared. 16 plus 16 gives you 32. X squared. You take the square root of each side. This is x. And this simplifies. You have 16 and 2. So what's the square root of 16? That's right, it's 4. And what's the square root of 2? Yeah, you can't do it. It's 1 point something, but you can't do it. So you just leave it as the square root of 2. So this is 4 square root of 2. Now, what you're going to do now is find the 6 trig functions, because now you have all 4 sides. Now the main 3 is so, ka, to, right? Sine is the opposite over hypotenuse. So sine theta equals, well, the opposite is -4 over the hypotenuse, which is 4 square root of 2. Now you can simplify that. The 4's cancel out. So you're left with -1 square root of 2. But you also might be told to rationalize it. That means that you can't have any square roots in the denominator. So you have to multiply the top and the bottom by square root of 2. When you do that, you get -2 square root of 2 over 2. Next, what you want to do is cosine theta. cosine is the adjacent over hypotenuse. So that would be 4 over 4 square root of 2. The 4's cancel out, just like before. So you have 1 over square root of 2, which, again, if you have to rationalize the denominator, you multiply the top and the bottom by square root of 2. Square root of 2 times square root of 2 gives you square root of 4. Square root of 4 is 2. So that's square root of 2 over 2. Now you have your tangents. Your tangents of theta is opposites over adjacents. Opposites over adjacent. Your opposite is negative 4. And your adjacent is 4. What's negative 4 over 4 when you simplify it? Yeah, it's just going to be negative 1. Now, I ran out of space. So, what I'm going to do, take my eraser, and I'm going to erase this part. I erase everywhere I don't need anymore. Alright, so we're going to need that triangle. So then you have the reciprocal functions. You have cosecant of theta. Cosecant of theta is you're going to take this and you flip it. Now, I can take this and flip it, but what I'm going to do is I'm going to take this, they're both the same. I'm going to take this and I'm going to flip this. When I flip it, it's going to be negative square root of 2 over 1, and I don't have to write the 1 because it's implied. Then you have secant of theta, which is the reciprocal function of cosine. So you take this and you flip it. Now again, I'm not going to take this, I'm going to take this. Because if I take this and I flip it, I would have to rationalize the denominator. And I want to save as much work as possible, so I'm just going to use this. So that's, when I flip it, it's square root of 2 over 1, which is just square root of 2. Then I have cotangents of that angle. Cotangents is the adjacent over the opposite. So it's going to be negative 1 flipped, which is going to be negative 1. And that's it. It was a lot of work, and hopefully that made sense.